Here's another two problems from the same thing we did with video 5. We're going to be converting this to a power series, and the series x to the n has a convergence, interval of convergence from -1 to 1. So we're going to use that when dealing with this. The center for these, a is going to be 1 for this one and 2 for the second one, but let's break these down here. So let's take a look at 38. Same process as before. So note that 1 over 2 minus x, that equals 1 over 1 plus 1 minus x. All right, and that equals 1 over 1 minus the quantity x minus 1 when I distribute a -1 out of that. So because we have that, this is going to equal the sum of n equals 0 to infinity of our x in this case is going to be x minus 1, and that goes to the n. So that's our power series. Now, we need to evaluate it. We'll use the ratio test. So we want the limit as n approaches infinity. And we're going to take this absolute value of x minus 1 to the n plus 1 over x minus 1 to the n. And that one's easy to do. It's just going to simply be the absolute value of that x minus 1. Now, n has no play in this, so we just need to have this less than 1. So to converge, absolute value of x minus 1 has to be strictly less than 1. And that's the same thing as saying x minus 1. So -1 is less than x minus 1, which is less than 1. Excuse me. And then when I add 1 to each, I'm going to go here to 0, x, and 2. So my interval of convergence, I, is going to go from 0 to 2. So that's the first one. That wasn't too terrible. I didn't give myself proper room probably for 42, but we'll see what we can do here. We'll go to another color. All right, so first of all, we'll just deal with this. This is going to be equal to x squared, and what can we do to factor that out there? Well, if we want to complete the square, we can have an x squared minus 4x, and we have to divide that by 2 and square. That's going to give us an additional 4, it looks like. And then we have a 5 there, so we're going to have 1 left over. So that's going to equal x squared over x minus 2 quantity squared plus 1. Now we need to put it into this form up here, this 1 over 1 minus something. So in order to make it a minus, we're going to do the same trick we did before. So we'll move the 1 over, minus a minus. And that's what we have. So this equals the sum n equals 0 to infinity of, we've got a minus there, so we've got this minus 1, so minus 1 to the n times the quantity x minus 2 squared, all to the n. We can break it into 2, whatever, but that's what it comes out to. So this 1 times, what do we have, x minus 2 to the 2n. We deal with it that way. So let's use the ratio test again. All right, so we need the limit as n goes to infinity of, oh, excuse me, there's an n there. This whole guy to the n plus 1. to quantity n plus 1. Don't make it just 2n plus 1. That doesn't work. And then we have that. 2n. Well, that's not too bad. So we have -1 to the 1, which is just -1. Now that's going to be in a parentheses, so that's not going to be much of an issue. And then over here we have 2n plus 2 minus 2n, which will just give us 2. So x minus 2 quantity squared. Well, this equals, there's no n in here. The -1 doesn't matter. Absolute value -1 is 1. So this is equal to the absolute value of quantity x minus 2 squared. So ultimately we need that to be less than 1. So that means that we have x minus 2 has to be less than -1, has to be less than 1, and this is because that that value squared has to be a number between -1 and 1. So the value x minus 2 must as well. And then we add 2 to each side, we get a 1 on the bottom, and then a 3 on the top. So that means our interval of convergence goes from 1 to 3.